Hello, my name is Sophia and I'm going to be demonstrating an example of how to solve a rational inequality. Solving rational inequalities is important because we can compare one or more rational functions with the same independent variable and find values to satisfy the expected relationship. The first step is to state the restrictions. We know that a denominator cannot equal 0, so x cannot equal -4 or -1. The next step is to move all of the expressions to one side of the inequality. We're going to move this expression to the left side by adding 112 over x plus 4 to both sides. Now we want to combine everything into one rational expression. To do this, we must find the lowest common denominator, which would be x plus 1 times x plus 4, and multiply each expression on the top and bottom to match the lowest common denominator. Next, we need to simplify the numerator, and we can do this by expanding all the brackets and collecting all the like terms. Now we have a simplified rational expression, and we want to factor everything as much as possible to find the zeros, vertical asymptotes, and possible wholes. The bottom is already factored, so let's go ahead and factor the top polynomial expression. Using the integral zero theorem, the factors of this expression are among the factors of the constant term, -24. We keep substituting these values into x in the equation until we get a y value of 0. X minus 2 is a factor, so we can use synthetic division to find the expression. We can factor this quadratic, and this is our factored expression. Now we can substitute the factored expression back into the numerator. The last but most important part is to make a sign chart. It's a great way to figure out the signs of the intervals before and after each significant point of the function, the zeros, the vertical asymptotes, and the wholes. On the left column of the chart, we list all of the factors on the numerator, then all of the factors on the denominator, then f of x, which is the whole function. On the top of the chart, we list out in order from least to greatest, the significant points. There are no wholes, the vertical asymptotes are -4 and -1, and the zeros are 2, 3, and 4. Then we look at each factor on the left column and write down negative signs for the x intervals where it will be negative, and positive signs for the intervals where it will be positive. For example, x minus 2 will be negative for the x values lower than 2 and positive for x values greater than 2. Do this for all of the factors. Once we get to the last row, it's important to remember our restrictions. We should always remember to write a does not exist sign on the restricted values because it should never be included in our final answer. For each column, multiply the signs of the numerator, then divide that by the product of the signs of the denominator, and write the final sign on the bottom. For the first column, 3 negatives on the numerator make a negative, 2 negatives on the denominator make a positive, and a negative divided by a positive equals a negative. Therefore, the final sign on that interval will be negative. Do that for each column to find the signs of the function on each interval. Finally, this inequality is asking for the x intervals where the y value of the function is strictly greater than 0 or positive. This would be between -4 and -1, 2 and 3, and 4 to infinity, all non-inclusive. And this is our final answer in interval notation and set notation. Thank you for watching.